So the second half of chapter 4, section 4.5 onwards, we're talking about translating graphs, and the decision we have to make, or I have to make at this point, is how much of this to recap from GCSE. Now what I've decided to do is I will remind you what the facts are, I will give you a few tips of things that my classes have struggled with in the past, but I will not go through why these algebraic changes, why adding on an A here and adding on an A here make these translations happen to the graph, exactly why those things happen. What I'd suggest you do is have a think about it yourself and recap your GCSE. If it is the case that that's not good enough and you'd like a video with that, then by all means leave me a message. I'm trying to get through as much of the textbook as I can, so rather than recap too much of the finicky details of GCSE, we'll plough on. If you want to, just as a quick hint, hopefully you can think of how these work for yourself, but just think about it as take the x coordinate and substitute it into f of x. That gives you the y coordinate for y equals f of x. Why should it be that if I take that y coordinate, f of x, and I add a to it, that makes the whole graph slide upwards? Okay, and if you follow that logic through, hopefully you can remind yourself why those things are always true. So a couple of things. First of all, we get y equals f of x and then add an a on outside, y equals f of x plus a. If I get those, this one, it's a y direction translation. If I get this one, it's an x direction translation. And that pattern carries on all the way through. Y equals a times f of x is a stretch in the y direction. Y equals f times ax is a stretch in the x direction. Y equals minus f of x. Now this one, I'm going to claim is a y direction reflection. Now if you so some people that I teach like thinking of it this way, other people find this confusing. I like this pattern. It's always in the y direction. Now I'm going to say that if you're going in the y direction, that point there would be reflected to down here. So it's a reflection in the x-axis. Okay? A y direction reflection is an x-axis reflection. And that would leave this one, f of minus x, to be an x direction reflection. And the reflection in the x direction is a reflection in the y axis. Now, if you don't like that way of thinking of these ones, you're going to have to come up with your own, minus sign there, you're going to have to come up with your own way of remembering it, but that's something that works for me. It works for some people that I teach. Other people say, no, that's just getting confusing. I'm going to need to remember it a different way. Fair enough. So, the other advice, which hopefully you've seen this sort of thing before, is things outside the brackets go the way that you'd expect them. So, adding on a outside the brackets, that is a slide by a factor of a upwards. Adding on a inside the brackets would take you left by a. Okay, this one is a stretch by a factor of a. This one squashes the graph in, so it's a stretch by a factor of 1 over a. So if this was an a, I'd half all the x coordinates and slide the graph in. Okay. Now, all of that hopefully is familiar from GCSE, and the way they ask the questions should be similar sorts of things. So let's have a look at this first one. Y equals x squared. Well, if we replace the x with an x minus 2, that's an inside the bracket thing. That's f of x minus 2. So f of x is x squared. If you take away the 2 first, then you square it, you've got an inside the brackets. So we're going to move in the x direction. It's a minus 2. We do the opposite of what we think. We slide it to the right 2. Y equals x squared plus 2. The function is square x, add 2 to it, and you slid it up, okay? What I often advise students to do here is to think of it, let's try and take an example from the exercise. So let's say if we had y equals x minus 3 cubed plus 4, well, in that case, y equals x cubed is the cubed bit is the bit that gives it its shape, isn't it? And what we're doing arithmetically is we're doing, we start with x. The first thing we do is we minus 3. The next thing we do is we cube it. So take what we've got and cube it. The next thing we do is add 4. Okay? This is the thing that gives the graphic shape. So the shape comes at this point in the process. Anything before is the inside the brackets. Anything afterwards is outside. So f of x minus 3 plus 4. So I take the y equals x cubed graph and I do the transformations in that way, right? Slide to the right and then up 4 spaces, right? So that's one way of thinking about it. If you're not sure if it's an inside or an outside or an f of, where the f comes in and where the function takes over, where the x cubed function takes over. There isn't much else to say because, again, this is GCSE but harder. It doesn't mean that it's easy. They're taking some of the hardest things from GCSE. They're asking you to be able to do that fluently and smoothly, and it just really needs a lot of practice. When it comes to the transforming functions, the point they're trying to make is you can do this with any graph. It doesn't have to be a cubic or a quadratic. It could be the new quartics that we've just learnt about. It could be any old shape without even having to know whether this is a cubic or something that just happens to look like a cubic. We can take this graph. If we know it's called y equals f of x, y equals f of x plus 1 would slide the whole graph to the left 1 space. So you can work out what that does. It's not going to move it up and down. It's not going to stretch it up and down, so the y coordinates stay the same. The x coordinates are all going to change by 1. It may seem that I'm being a little bit brief here. I'm not going through everything, but that's because if you started this course, hopefully your GCSE grade is pretty good, and if your GCSE grade is pretty good, you understand this. You learnt this at some point. So it might be that you need to go back into GCSE material and recap. But other than that, we are at the end of chapter 4. Enjoy the mixed exercise.